Good morning, everybody. This is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering, Department of Electrical and Electronics Engineering. Chemistry topic about investigation of lithium intersalation metal oxides for thermal batteries. Investigation of lithium intersalation metal oxides for thermal batteries. Introduction. Consider interest exists in lithium metal oxide due to their application potential as rechargeable batteries, electrodes, and electrochromic displays. These oxides derive their interesting properties from the large stability region they have with respect to lithium content. In some materials, the ratio of lithium to metal ions can be varied between 0 to 1 without substantial changes to the structure of a material. The topolytic line intersalation mechanism is the basic form of material applications as an electrode in a rechargeable battery when used as a cathodic electrode. For example, Li is accumulated in the oxide structure during discharge cycle of a battery and is removed again upon charging. It is believed that Li is fully ionized in most lithium metal oxides, which donates its electrons to the most host bands without such efficiency in them. This makes it possible to control a band filling of the host material varying the Li content electrochemically. The electrochromic applications band filling is used to adjust the electronic and optical properties. This is about the investigation of lithium intercalciation metal oxide from the thermal batteries. Shows schematically an electrochemical lithium cell, two electrodes, an anode and cathode. The separation by an electrolyte. The electrolyte allows transfer of ion in between the anode and cathode, but does not allow an electron transport. In most applications, the electrolyte is liquid, although gases 4 and solid polymers 5 are being investigated as more versatile alternatives. The equilibrium voltage difference between the two electrodes, also referred to as the open circuit OCV, depends on the difference of a lithium chemical potential between the anode. The formula is V concurrence to X. 52 milli lithium cathode concurrence to X. 2 ml lithium anode ZF. F is the Faraday constant and Z is the charge of electrons in electrons transported by lithium of an electrolyte. In most non-electro non-electronically non-electronically conducting electrolytes, Z51 in Li intercalciation for a battery and cathode. Investigation of lithium intersalation metal oxides of thermal batteries. The diagram is here. Copper current collector, anode graphite separation, and cathode aluminum current collector is sent into 5 mole liter of C4H6O5 plus volume percentage of H2O2. Temperature equal to 90 degrees Celsius with 60 minutes respectively for 300 rpm. MnCH3COO2 4H2O is mixed into lethicate mixing well with lithium and transaction metal oxides. Evaporation takes place, the precursor and the stage of heat transmitter is at 150 degrees Celsius for 30 minutes. From starting chamber, the heat is transferred with 500 degrees Celsius of 4 hours time duration, and the second chamber gives the 850 degrees Celsius with 16 hours and cooling the room temperature of NCM. Finally, the given output is elenchicated with lithium intersalation of metal oxides. Analysis of thermal lithium over time. Anode current collector copper. Electrolyte lithium salt dissolved in organic solvent with two respective divisions. Cathode current collector in an aluminum. Anode carbon separation separator. SEI layer is followed by the electrolyte lithium salts dissolved in the organic solvent. Cathode lithium metal oxide is attached with the second the force part of electrolyte lithium organic solvent with the respective the anode collector. Current carrying cathode current collector at aluminum and which is attached to the cathode, and anode current collector copper anode to copper connector between two layers is divided into SEI layer with respect to their electrolytes separated by two divisions. Now coming to what is lithium. Generally the lithium is the lightest of metal because it has the capability of the light weight of a metal, high capacity of storage of energy 370 to 300 watt hour by centimeter cube. That's the reason the lithium ion batteries we use in our mobiles. High electrochemical reduction potential is generally in lithium. Highly reliable is found in lithium. Spread thermal range up to minus 25 degrees Celsius to plus 40 degrees Celsius. This is the temperature of lithium from minus 25 degrees Celsius to 40 degrees Celsius. These are the limitations and applications of lithium. The intersalyatic process. Now we are having two types. One is negative electrode and the positive electrode. We can see the special carbons in the negative electrode and positive electrode. Positive electrode containing carbon dioxide, oxygen and lithium, which is double bonded with each other in positive terminal. The process of intersalated in lithium ion batteries. Lithium components are used to anode and non-metallic lithium batteries. These two batteries are subdivided as negative electrode and positive to show the variation between the special carbon and lithium carbon or oxygen. Intersalated process. Cathode and anode. LiNiO2, LiCOO2 at cathode and anode graphite lithium C6. Cathode. Positive electrode lithium compound symphonic valency lithium COO2 most common or LiMn2O4 moil. New property blends here in the positive electrode with respect of lithium component at cathode. Anode negative electrode is followed by carbon coke 4.1 V max CV charge old technology and nano composites new properties of technologies. Graphite 4.2 V max voltage max CV charge current technology. These two are interdependent on anode and cathode. Solid electrolyte interface SEI. The layer formed instantaneously upon contact of L with the solution consists of insoluble and partially soluble reduction properties of electrolyte component. The SEI solid electrolyte interface is generally having electrode material, current collector at copper, additive binder, additive material, additive binder and separation of current collector AI. We can see them here. Coming to the report and conclusion, an investigation of a new high voltage cathode materials in thermal batteries include a group of lithium intercalation metal oxide compounds. An author represents the experimental result of high voltage cathode studies of discussion the applicabilities materials and thermal batteries. The intention of this research work was to discover a new positive electrode that by virtue of higher discharge voltage than the comparable capacities of iron FES sub by 2 would result in new technology offering increased performance, lighter battery weights through stack volume reductions, and manufacturing cost savings. With high voltage cathode material, we can also investigate other including groups of lithium intercalation metal oxide compounds.